In this example, we're going to take a vector file previously created in the software, and using the vectors in the file, we'll look at modelling the sign using the modelling tools. We'll also look at how we can incorporate free clip art that comes with the software to complete the design. And to finish, we'll walk you through the toolpath setup to cut the sign that you can see here. So let's go to File, Close. So let's go and open an existing file. So from the Shell Signs Files project folder, we're going to open up the Shell Sign vectordrawing.crv 3D file. Okay, so here we have a set of vectors. If we go over to the View toolbar at the top, we're going to use this icon here to tile our windows so we can see the 2D view on the left, and we also have the 3D view on the right hand side. So we're going to look at using these vectors to create our model. So to do that, we need to go over into the Modelling tab. So the Modelling tab is divided up into two sections. The top portion has all of the icons to create and edit 3D shapes. And then the lower half of the Modelling tab is what we call our component tree. And this is where we can view and organise our components into levels and see the results of the components and their levels, their order in the list and their combined modes in the 3D view. And this is what we call the composite model. Now, as we have no components in our list, we have no components visible in the 3D view, and all we are presented with is the modelling plane. Now, in our component tree, by default we have a level, and if we create components now, they'll be added to this level. The level concept is a smart way for me to organise my components, add multiple levels, change the combined modes of the levels as well as the components within the levels to create the desired composite model. So first off, we're going to look at creating the base shape for our sign. We're going to look at two different modelling tools. First off, we're going to take this vector here, and we're going to look at using the Create Shape Modelling tool. That will enable us to assign a profile with an angle to create the desired shape that we require. In this case, we want to go with a domed effect. Secondly, we're going to look at taking this vector as well as this vector here, and we'd like to take this profile and sweep that in between the two vectors to create the border for the base shape. And so with that, we're actually going to organise our component tree right from the start. And so we're going to right click on level 1, and we're just going to go to this option here to rename that level, and we're going to call this level the base level. And then everything that we create here will be added to what we're calling the base shapes for our sign. So let's start by selecting this outer vector here. And we're going to go over to the modelling tools. Using this first icon here, we're going to create a shape from the vector outline. So if we click on that, that will open up the Create Shape tool. And so the way that this tool works is we can assign a shape profile along with an angle to any given closed vector. So we've got a closed vector here, and here we can look at assigning a curved profile, an angled profile, or we could look at giving that a flat height. In this case, we want to go with the curved profile. And so that curved profile will give us a dome effect. Okay, so now what we can do is we can look at altering the angle that we're going to create. So I can just use the slider here. If I let go, you'll see that the software has automatically created a shape for me based on the settings that we have within our form. Okay, so we can increase the angle if we wanted to, or we could look at decreasing that. Now in this case, we can see that we have a fairly flat shape in the centre here. And the reason for that is all down to the final height, where we're limiting the height of our component to a specified height that we're putting in here. In this case, we want to use the no limit option, so we're not creating a limit to the height, it's just going to scale out in proportion to the angle that we assign along with the width of the vector that we are using. Now in this case, what we could do is we can apply a specific angle if we wanted to by typing in a value. So for example, let's type in 30 in there, press spacebar to accept that, and you'll see that the software will automatically update that here in the 3D view. Okay, so that looks pretty good. So we can just put that back in Z. And working our way down the form, we can set the combine mode of this component. So we can say we want that to add, and then we can give that component a name. In this case, we're going to call this one dome, and then we can simply press apply, and that will apply those settings, and then we can close out of the create shape form. And so now we can see that I have a component within our component tree named dome, and that's because we named that in the create shape form. I have a grayscale representation of our component here in the 2D view, and I have the actual 3D model here in the 3D view. And if I select that component, you'll see it's highlighted here in the component tree. It's also highlighted the 2D grayscale of the component, as well as highlighting the actual 3D part. So now we're going to look at creating the 2-rail sweep for the border of our sign. And so to do that, we need to come over to the second icon in the Model and Tools list, whereby we're going to create a 2-rail sweep. So let's just click on that, and that will open up the 2-rail sweep form. So the way that this tool works is it requires us to have 2 vectors that are going to represent the rails, and then we'll select a third vector that would represent a cross section that gets swept between the 2 rails. So to start with, we're going to select the outer vector first. We're going to hold down Shift and select the inner vector, and then we're going to use this option here to use selection. And so those vectors have now been transformed into drive rails. Okay, so we have a red rail, that's because we selected that vector first, and we have a green rail, which is the second vector that we selected. We can see that we have arrows going in an anti-clockwise motion on both of those rails, and that's just indicating to us that this will be the direction that our cross section will travel between the 2 rails. And then here we can see the start point. So the start in here, and it will sweep the profile around until it meets its start point again. So with those selected, we can now hold down Shift and we can select our cross section. Okay, so we're going to undraw all of these options. We're going to set the combine mode of this to add, so it adds on top of the dome that we currently have. And then we're going to give this component a name. We're going to call this one border, and then we can go ahead and press apply. And we can see the result of that there. So you can see that profile shape being swept around our part between the 2 vector rails. So we'll put that back in Z, and then we can close out of the 2-rail sweep form. So far we've created shapes using vectors and the modelling tools. Now the next set of shapes that we're going to look at are going to be imported into our session, where we'll look at using some of the free clip art that comes with the software to complete our design. Now I'd like to bring in a banner that's going to blend in with the bottom portion of our sign. And so to do that, as we're working with a new element of our design, we're going to come into our component tree and we're going to look at creating a new level. We'll right click on the base level, we'll use this option here to insert a new level, then we'll right click on level 1 and we'll rename that level, and we're going to call this one banner. Okay, now with that currently set to add, anything that we add into the banner level will ultimately add onto the base shapes that we've got here. Now as I mentioned, I want the banner blending in to our sign, so we need to change the combine mode of our banner by using the right click option, and we're going to go to the combine mode and we're going to set that to merge so everything blends in. So now we can look at importing our banner clip art. So to do that, we can come over to the modelling tools, use this option here to import a component or a 3D model. From the project folder, we can see the banner .3D clip file there, and we could simply go ahead and press open. We can see that that banner component has been added into the banner level. Let's just look at simplifying the name of that. So we'll just right click, rename that, and we're just going to delete all the numbers afterwards so that we're just left with the banner component. And so we can only see the model in our work area. So only the area of the model that overlaps the white space here will be visible in the 3D view. Now the size and the position of the model will always be dictated by wherever it was saved from in the original file that it was saved in, where this was centered around 0, 0. And so we're going to take the banner component and we're going to look at aligning that part to the center of our job. So with that selected, let's go over to the alignment tools, and we're going to use this option here whereby we're going to align it to the center of our material both vertically and horizontally. So if we click on that, you can see that it's been moved to the center of the job, and then we can simply close out there. We can take that and we can also look at sizing that. So with that selected, let's go over to the set size option here. So here we're going to size it with the anchor point in the center of the component, and then we're going to size it by altering the width or the height, and with link XY checked, whichever X or Y value we change, it will scale the other one in proportion. So we're going to look at giving this a width of 13. And then also with the option to auto scale Z, it will also update the thickness of our component as well. And so when we go ahead and press apply, we can see that it's done that there, and it's created more height in the component because of the auto scale Z option. So now I can close out of the form. So as I said, I want this banner in the lower half of our model. I want it so that the text just sits nicely on top of the width of the banner. So with that component selected, we're going to go over to transform objects and we're going to move this. So here we have the option to move that relative to its current position, or we can move it to an absolute position within our job space, whereby the move will be dependent on the anchor point. In this case, we're going to move that relative to its current position. We want to move it down the y-axis. So here we're going to use the y position, whereby we're going to enter in a negative value because we're going down, and we're going to put in 1.6 in this example, and then press apply, and we can see that's been moved down the y-axis, and now the Ocean Drive text sits nicely within that banner there. So then we can close out of the form. Let's maximize the 3D view. And so looking at the overall composition, we can see that there are some areas of the banner being obscured by the base shape, and the software has highlighted those areas with a green colour. And so what we need to do is we need to look at assigning more height to the ribbon to ensure that it is proud of the base shape, if that was the effect we were looking for. In this case, I do want the banner stood proud of the base shape, so we need to look at the properties here. Now whilst we're in the 3D view, I can click on that again, and that will put that part into transform mode. And we can see that we have a blue square at the bottom here, and if I click on that square, that will open up the component properties form, in which case I can look at altering the shape height, and I can also look at applying a base height. So in this case we could look at assigning a base height. So a base height is basically a flat height that we're going to apply underneath the component just to raise it up. In this case, we could go with a value here of, let's say, 0.15, press spacebar to enter that in, and you can see it's now lifted that up in front of the base shapes there, but now we've got quite a lot of height in here. So we could even look at maybe reducing the shape height of the banner. So here it's currently at 0.5364. So we could see if we could get away with going to 0.4, and we can still see that we're in front of the dome shape in the background, and we've dramatically reduced the height there of the actual banner itself. So I'll put that back in C. So now that I'm happy with how the heights are interacting with each other here in our composite model, we can now look at the next part of our design. So I'd like to add a decorative motif that's going to sit on top of the base shape here. So as we're working with a new part of our design, I'm actually going to introduce a new level. So to create a new level, we're going to right click on the banner level, we're going to insert a new level, and to right click on that level, we're going to rename that level, and we're going to call this one Details. I'm going to leave the combine mode of this level to add. The reason for that is whatever I add into this level, I want it to add on top of our composite model. So let's have a look at bringing a piece of clip art to finish off the 3D part of our sign. So I showed you earlier how we could use this folder option to import components from a folder location. Well, this time we're going to look at how we can make use of the clip art tab. So the clip art tab will enlist all of the clip art that's available to me, whether I've got it installed or not. Now, if you're connected to the internet, you may find that some of your clip art will have these arrows on, and that's the software's way of telling you that you currently don't have that installed. But if you click on this option, you can log into your V&Co account to download the clip art directly into your software. Now in this case, I'd like to add in something decorative, so we'll go into the decorative section of our clip art, and I can scroll through until I find something that I like the look of. So in this case, I kind of like the look of this scallop shell here, and if I double click on that, that will bring that into the center of my job. And so we can see that that is far too big, so we could look at sizing this. So if we go into the modeling tab, we can use this option here to set selected object size. So here we're going to size this where the anchor point is in the center of our shell. And then we're going to look at altering the width. So again, we're keeping link XY checked. We're also keeping the auto scale Z checked here. And we're just going to look at altering the width, and that's going to scale out the height along with the Z in proportion to whatever we change here. In this case, we'll just go with 4.8, and we could go ahead and press apply, and then we can close out. So the last thing we need to do is just move the shell up in the y-axis. So let's go over to move selected objects, and then in the y we're going to go with 0.9 in there, and then go ahead and press apply, and that will move that up by 0.9 of an inch relative to where it was before. So I like the sign that we've got here so far. So what we need to do now is we need to just look at creating a vector that represents the outline of our 3D model for when we come to do a cutout pass when we get to the toolpath stage. So to do this, let's just go ahead and tile our windows so we can see the 2D view on the left and the 3D view on the right hand side. So we're just going to take the vectors that we don't need by selecting them, holding down Shift, and then selecting the other vectors. So it's just the two borders and the profile. And then we're just going to right click, and we're going to use the option here to move to layer. So we're going to move them onto a new layer. We'll just call that one layer 2. We're going to make that invisible so we can't see it anymore in the 2D view. We're also going to make that inactive. Then we could go ahead and press OK, and you'll see now that those vectors have disappeared. But if we go to our layers tab, you'll see that we now have layer 2, and it's currently switched off. And if I switch on the visibility of layer 2 by clicking on this light bulb, you'll see those vectors have now appeared again. So we're just going to undraw the visibility of layer 2 there, and then we're going to go back into the modeling tab. And so to create a vector boundary of our part, all I need to do is select all of my components. I'm going to hold down Shift and select dome, so everything is highlighted here. And then in the modeling tools, we've got this option here to create a vector boundary around the selected components, and it will basically create a boundary around the outermost part of the components that we've got selected. So we can click on that, and then if we just click into the white space here, we can see it, that vector has been added in there, and that represents the outline of our overall shape. So now that we're content with how our part looks, we can now think about creating some toolpaths for our part. So we're going to use this option here to switch over to the toolpath side of the software, and that will just close out of the design side. So over here, the first and most important thing that we must do is check over our material setup. And so everything in this form really is just relating to the actual material block that we're going to use to cut our design into. So here we must specify the thickness. In this case, we're going with 3/4 of an inch. Then we need to specify the XY datum position, and so this is where we tell the software where on the machine we want to set the X0, Y0. In this case, I'm going to go with the lower left hand corner because that's typically the way most CNC machines are referenced from. That way the X and the Y values will always be positive, but you should always pick one that's suitable for your machine. Then we need to tell the software where we intend on setting our Z0 position, whether that's on the material surface or on the machine bed. In this example, we're going to set that off the material block on the material surface. Next up, we've got to look at the model position in the material. So this is where the software wants to know whereabouts your model is going to fit within the thickness of your material. And we can see straight away we're actually displayed with an error that the model thickness exceeds the material thickness, and we can see the model thickness shown here is 0.8362, which is much higher than the actual thickness that we are using. So we have two options here. We could alter the thickness where we could get a thicker material to use that's thicker than the 0.8362 model thickness, or if we can get away with it, we could look at shrinking down the actual model thickness itself. So let's have a look at that. So we'll use this set option here. Here we're going to enter in a height, and we're just going to change the model height here to 0.55, press apply, and then we can close out, and you can still see that we haven't lost too much detail there, so I'm okay with that. So I'll put that back in Z. And so now that we've done that, we can actually look at positioning the model within our block of material. So this lighter area represents the thickness of our model, and the darker area represents the thickness of the material that we're planning to cut into. Okay, so it's always a good idea to apply a small gap above the model so that if there are any discrepancies in your material flatness or how you set the Z0, you'll make sure that you avoid any flat spots. And so in this case, we're just going to go with a small gap above of 0.05 in this case, and that will leave a space below of 0.15. So we're going to have 0.15 material added on extra underneath our model. Then we need to check over the rapid Z gaps, the clearance and the plunge settings, ensuring that they're safe and appropriate for our setup along with our home and start position, and then you could go ahead and press OK. So the first two toolpaths we're going to look at are 3D toolpaths. The first is a 3D roughen toolpath that will enable us to use a large tool to hog away at the majority of the material. Then we'll go in afterwards with a 3D finish toolpath, which uses a smaller tool in order for us to get out all of the finer details within our part. So let's go over to the 3D roughen toolpath. So the first thing we need to do is assign a tool to this toolpath. So if we use this select option here, that will open up the tool database. Here I have access to all of the default tools that we have that's appropriate to hardwood material and a large format CNC machine. So in this case, I'm going to go with the 1/4 inch end mill. I can check over the settings, ensuring that they're safe and appropriate for what I'm cutting into. And then we move on to the machining limit boundary. Okay, we already have a vector that represents the outline of our sign, and so we could look at using this selected vector to govern the area that we're actually going to be machining at. Now, because we are working with a positive shape, it will be a good idea for me to input a boundary offset. And that's just so that the center of the tool doesn't just come up to the vector, but it's going to come past it by the amount that we offset it by, so that it can cut down the sides of our model. And so a good offset to use is the radius of the tool plus the machining allowance. So in this case, we're going to go with an offset of 0.18. So next we need to specify a machine allowance. So this is a skin of material that the software will leave on the model to protect the finish so that the larger tool doesn't chip at the surface of our finished part. So here we're just going to go with a value of 0.03 in this case. Then we need to specify our roughing strategy. In this case, we're going to do this as a Z-level strategy. So we're going to cut the parts in 2D toolpaths going along the X-axis. Then we could go ahead and give our toolpath a name. In this case, we're just going to call this one 3D roughing sign, and then we could go ahead and calculate that. And then the software will automatically open the preview toolpaths form, where we can see the toolpath represented by the blue lines, and I can look to simulate the toolpath being cut in this virtual block of material. Now this preview literally represents the coordinates that the software is going to tell the tool to move to in order to carve the sign out. And this is very useful for me to see the actual paths here, but it's more useful for me to visualize the actual cutout simulation, and that's what this preview function is for. And so with this preview, we could look to alter the material, the virtual block that we've got here. So we have various different woods, we've got metals, stones and plastics. You could add your own texture in here if you'd like to. In this case, I do intend to cut this sign out of cherry, so I'm going to use the cherry to simulate our preview into this block of wood. And then we can simply use the option to animate the preview. We can draw the tool if we wanted to, and then we could simply go ahead and preview that toolpath. And what we're seeing here is an exact simulation of what we'd see if we were to cut this out on our own CNC machine into our actual block of material. And so if we take a look in the 3D view, we can see all of the steps there, all of those 2D toolpaths to create the 3D shape that's starting to come through there. So now we're going to look at using a smaller tool to get in all of the detail that we originally had in our model. So let's close out the preview toolpaths form, and we're going to go into the 3D finish toolpath. So the first thing we need to do is select a tool. In this case, I can see the tool that I want to use is actually currently selected. So we're going to look at the 1/8 inch ball nose, and then we can use the select option there. Okay, here again, we're going to use the selected vector for our machining limit boundary, whereby we're going to input an offset here of 0.1 in this case. Then we can choose how we're going to machine this, whether we do that as an offset strategy, or we could look at doing that in a raster strategy. In this case, I'd like to do that in a raster strategy, whereby we're going to put in an angle of 90 degrees, and so that's going to cut along the y-axis. Okay, so then what we can do is we could go ahead and give that a name, call that 3D finish sign, and then we could go ahead and calculate that. The software will just take a moment to calculate those settings, and then it will open up the preview toolpaths form, in which case again we could go ahead and preview that toolpath. And so you can see it's cutting along the y-axis, and we're starting to get all of the detail there using that smaller tool. So I'm happy with the detail that that tool has pulled out there. So now I could go on and look at using a VCarve toolpath where we're going to VCarve this text into this banner. So let's put that in Z and we'll close out of the preview toolpaths form and we're going to go into the VCarve toolpath. So the start depth for this, we're going to keep that at 0, okay? We're keeping it at 0 because we're actually going to look at projecting this toolpath onto our model. And so the software will just look down and see where our banner is, and then it will reference the banner as the 0 point in which the VCarve toolpath can begin to carve into. Okay, we also need to make sure that we have our text selected. So we're VCarving into the 451 Ocean Drive text, start depth of 0, and then we need to select a tool. So we use the select option here. So in here, we're going to go to the V-bit section, and I'm going to use the 90° half-inch V-bit, use the select option here, and then we can give that a name. We're going to call this one VCarve sign. We're going to check the option here to project the toolpath onto the 3D model, and then we can calculate that, and then we could go ahead and preview that to see how that looks. Okay, so I think we've got a very good effect there, and I like what we've got. So we'll just put that in C, and then we'll close out of the preview toolpath form. So all we need to do now is create a toolpath that's going to cut our sign out of our block of material. So we're going to take this vector here, and then we're going to go over into the profile toolpath. So here we need to specify the start depth and the cut depth. So we're starting this at 0 and we're cutting all the way through our material, which is 3/4 of an inch. Now the tool I want to use actually is a 1/4 inch end mill, and I can see that's currently assigned to this toolpath here. So we could use the edit option here just to glance over the settings, ensuring that they're safe and appropriate. I'm okay with that, so we'll press OK. Next we need to choose whether we machine the vectors outside, inside or on the vector. In this case we want to go around the outside. If you wanted to, you could add tabs to your toolpath. I'm just going to assume that I have an appropriate hold down method. For example, I could have a vacuum hold down, so that will hold my sign down. So I don't need to add tabs in this case. And then I could give that a name, and we're just going to call this one Profile Sign. Go ahead and press calculate. That will open up the preview toolpaths form. We could maximize the 3D view there. We could preview our toolpath, and that would be our cutout part. I can double click on this area here, and that will delete the waste material, and there we have a better view of what our sign will look like when we come to cut it out. And so it's very important that your part looks correct at this stage, as the toolpath preview shows you an accurate representation of what we would see on our CNC machine if we was to go ahead and run these toolpaths. So if something doesn't look as you wanted it here at this stage, you can go back and make edits to the toolpaths, recalculate them until you are satisfied with the results that you can see here in the toolpath preview. And that's what makes the toolpath preview such a powerful tool. Now if you was making this for a customer, at this stage what you could also do is look at using the save preview image option, and that will save the image as a bitmap, a JPEG, a PNG, in which you can then go ahead and send that off to your customer to proof before you actually machine the part. And so once you're content with your toolpath preview, you can now go ahead and save out your toolpaths. So we could close out of the preview toolpaths form, and then we could go over into the save toolpath option. So here we're just going to uncheck this option to output all visible toolpaths to one file. That would only work if you were using the same tool. In this case we are using a variety of tools in different operations. So we could look at the 3D roughing sign, and you'll see that it's in here in the toolpath to be saved, and then you simply go and choose an appropriate post processor. So the post processor is what will format the data for that particular machine, and so you need to choose one that is suitable for your own machine. And you can see that we have quite a lot of different post processors available here. In this case, I'm going to go with a generic G code here, use the option to save the toolpath, give that a name, save it out, and then you take that file over to your CNC machine to run on your material to carve the part out. And then you do the same for the remaining toolpaths to save out. And so that completes this tutorial. So we're going to go ahead and save the file. So let's close out here, and we'll go to File, Save As, and in the project folder we're going to call this one Shell Sign Getting Started, save out, and you can access that from there.